Okay. Okay. And so some substances actually do dissolve in water very well, but when those substances dissolve into water, they don't stay together. For example, sodium chloride. What happens to a salt crystal when you start to dissolve it into water?
Like what happens to the salt?
Yes.
It breaks it apart.
Part of the water.
Okay, so if I start with NaCl solid, that salt crystal is ripped apart, and Na positive and Cl negative
Yeah, you got through.
results. The symbol changes to AQ because those ions are now a part of a solution. What would the KQ expression look like for this? If you had to write a KQ expression for the dissolving of salt, what would it look like?
Would be 1 over Na plus Cl.
Ooh.
Actually, it'd be Na plus and then Cl brackets around because they
Okay, because KQ is always products over reactants. You have your salt crystal, which is made up of sodium ions and chloride ions. Those become your top. Guess what? NaCl solid doesn't appear in the KQ expression. When we use this specifically for a dissolving equation, we're actually not going to call this a KQ expression anymore. Instead, we are going to say something called SP. SP stands for solubility product. And it is telling you that it is an equilibrium expression for something that is being dissolved into water. We will see several different subscripts for K's. When we go into the acid and base unit, we will see something called Ka and Kb, because we will be writing equilibrium expressions for acids and bases.
color-coded that. We color-coded that.
If sodium chloride dissolves well into water, do you think we're going to see a high KSP value or a low KSP value?
What? I didn't get the.
What's the rule about K values?
Oh, like reactant favored and all that stuff?
Yes.
Okay.
So,
If K is larger than 1, then it's product favored.
it's product favored. If K is less than 1, it's
Reactant.
reactant favored. And if K is 1, that means the product and the reactant happen at exactly the same concentrations. So we would expect that sodium chloride would have a K value that would be greater than 1 because it dissolves fairly well into water. Other substances do not dissolve well into water at all. An example of this is barium sulfate. I'm going to clear the ink on the screen. While I do that, what I would like you to do is write the dissolving equation, that's this right here, for barium sulfate.
mass, molasses.
Barium sulfate is an ionic compound. If barium sulfate dissolves into water, what two ions are going to be produced?
Barium.
Okay, so barium ion and the sulfate ion. Barium sulfate does not dissolve very well in water. So if we were to write a K expression for this, we would have the concentration of the barium ions multiplied by the concentration of the sulfate ions. Would this K's K value be greater than 1, equal to 1, or less than 1? Barium sulfate does not dissolve well into water. Would the KSP value be greater than 1, equal to 1, or less than 1? Yes. It would be less than 1, which indicates that it's not breaking apart very well. Has anybody ever had to go for this type of a procedure? It's called a contrast X-ray.
I think it is. Yep.
You have to drink a chalky fluid.
I did.
That's right. It doesn't taste very pleasant. Basically, if you want to see what it tastes like, mash up chalk, mix it with water, and drink that. It's, yeah. Mm-hmm. What were they looking for?
To see if my esophagus was contracted.
Yeah. So they can look at the shape of the esophagus. If somebody's throwing up a lot, what is that going to do to the sides of the esophagus? Yeah. And they can actually use this procedure to look and see if there's erosions in the side of the esophagus. Oh yeah, it would be extraordinarily painful.
That sounds really gross, but
this is actually a pocket in the intestine. So I'm not sure whereabouts it is in the body, but it's some kind of a herniation, or it could be something called diverticulosis. Mm-hmm.
Are those ribs?
I'm not sure if they're ribs or if it's just a really close look and that's the backbone. It's hard to say. But normally, if you were to try to take an X-ray of soft tissue, you would not see it. The whole purpose of drinking this really gross and disgusting solution is to highlight the inside of the soft tissue and actually get a picture of it. But, gentlemen.
It was like I was talking about the drink. Like
Okay, so what do you say?
It was like if you took chalk and milk and ground together.
So it was just white?
Yeah.
it tastes bad.
Oh, really?
What?
And you have to drink all of it.
Yeah.
Was it like?
And they didn't give you a small cup. It was like a
Oh,
big
yeah.
cup too.
It's like half a liter of
Was it
this
like
stuff.
closer to a liquid or a solid?
It was
Like a
like
Jell-O?
It was like a. I don't know. Like it was kind of like a slushy.
It's like old
chalk.
So it's like a lot of powder.
Yeah. And you could like.
But think about it. How would the first person ever think, I'm going to drink me some chalky fluid and highlight my insides for an X-ray? Like, how did they ever even come up with that idea? No idea. Okay, the stuff that is doing the highlighting is the barium ions. It's toxic. it makes us extremely sick if we get barium ions into it. So how is it possible for us to drink barium sulfate and not die?
It breaks
American
water.
drink is.
It dissolves in water.
Does it?
Yeah.
But what does it tell you? It says this does not dissolve in water. The KSP value is very low. Okay, it's less than 1, which means if I have a glass of chalky fluid,
There's not very much in it. It's like very low concentration.
very, very low concentration of this stuff.
That's
And this is the stuff that would make me extremely sick. When it's locked in with sulfate, connected with sulfate, it will not make me sick. It will just go right through and come up to number 2.
So what's in laxatives then?
Oh gosh, there are many things that you can use as a laxative. So, for example, the spice anise and fenugreek. You have black licorice taste. Okay, that's due to the spice anise or fenugreek, and that makes the smooth muscles down there contract and push stuff out. You can take stuff to make you loosey-goosey by drawing, and what it basically does is it draws water into the large intestine, so there's more fluid for movement. It used to be, some people used to consume castor oil to lubricate the insides. You gotta be kind of careful about how much and how often you drink castor oil because it's really not good for the body in large amounts. But that will lubricate the waves, so to speak. So the question for that is, it depends on what it's made up of.
And what you want it to do, I guess.
Hey, you haven't been able to go in a couple of days, that's actually a problem.
Yeah, I didn't go for the entire week camp last year.
Not only is it very, very painful for somebody not to have a bowel movement, but there's lots of bacteria in feces, and if that bacteria crosses over into your bloodstream, your body will suffer from wide-scale infection called sepsis and organ failure. So it's not good, and it's extremely painful for the person.
Unless you drink a lot of water.
All right. So writing KSP expressions. When you write a KSP expression, you need to start by writing a dissolving equation. For example, if I have something like aluminum sulfate, that is made up of aluminum ions and sulfate ions. Then I can convert this into a KSP expression. Remember that solids are not going to appear in this KSP expression.
That's why it looks like
That's a solid, isn't it?
Can I go to the washroom?
Sure.
That's hilarious.
I can now.
Yeah, did you drink some water there, buddy?
It's gonna be bad.
Interesting.
Does he have like a dress code? I just saw
Okay.
it too much.
You're like, they're all in
Yeah, he took his shirt off and everything, or his sweater off and everything. But then these
Where
things don't
could
record.
you find data about KSP?
Oh, it is.
So what?
I can tell you exactly how it's totally.
You can actually find a data table in your blue book.
This
This one.
Looking for You're having a great day, hey? Alright, not that page, keep going. Not that page. Alright, there you go. Aha! So if you look through that, there is a number of compounds with KSP values that have been identified in there for you.
Oh, cool.
There is more data, but if you look at a lot of those KSP values, what do you notice about the numerical values? So if you look at that KSP table, times 10 to the, is it a positive exponent or a negative
they're
exponent?
all negative.
They're all negatives. These are all insoluble things. Okay. You're not going to find a KSP table for things that are very soluble, because it's just going to tell you that the KSP values are greater than 1. Please do B and C, iron carbonate and cobalt-3 sulfite. Iron 2 carbonate, if it dissolves, will break apart into Fe2 positive and CO3 negative. If there's more than one of that ion in a compound formula, you need to indicate that in the dissociation. So for example here, it says CO2 right there. That means that there's 2 cobalt-3 ions in there. When you write it out, that 2 goes in front of the cobalt. According to this, you have 3-part sulfate, indicated by the 3 outside of the bracket, which means that when I write out the sulfate ions, that 3 needs to go in front of the SO42 negative. Here, Na3PO4, I have 3 sodium, so I must indicate that in the dissociation. Why? Well, what's your next step going to be after you write out this dissociation? Once you've written out the dissociation equation, what are you going to have to do with this next? You're going to have to write a KSP expression. So if you haven't indicated that there's 2 parts cobalt, you're going to forget to square CO in the KSP expression. So your next job is to write your KSP expressions. Writing your dissociation equation properly is essential to doing your KSP expressions, because if there's more than one of an ion, that's going to appear as an exponent in your KSP expression.
Doesn't matter if, like, for the first one, Fe and CO3, it doesn't matter if those are switched or not.
So if it was CO3 to negative first and then Fe3 positive? No. It's a multiplication, so it's not going to matter which one comes first. What you have to be careful is that whatever the concentration of sulfate is, that's the one that has the exponent 3. And whatever the concentration of cobalt ions is, that's going to be squared. Start putting in the wrong numbers,
You're hooch.
you're going to start having challenges with this, because you're not going to find the exponents of square values. KSP only depends on the concentrations of ions in a saturated solution. However, to establish any equilibrium system, you have to have solid present. Okay? If there's no solid present, you have an unsaturated solution, and it's a one-way reaction. It's only when you have solid at the bottom of the beaker that you're reforming the crystal, and now you have the reverse reaction. Thankfully, scientists have already done all the hard work on this, and they've generalized solubility rules in Table 5. Okay, and you also have some known values for insoluble products on page 6. If KSP is very high, What is that telling you about solubility of that substance? What does a K value greater than 1 mean?
That is very soluble.
It's very, very soluble. Okay. Versus if you have a K value that's less than 1, that means that the crystal really is not dissociating very well. We would say that if something has a K value less than 1, it is not very soluble. So, why would we care? Why would we want to know about KSPs?
Well, for instance, like, I don't know what, the Alka-Seltzer tablets, I think that's what they're called.
Mm-hmm.
It could be experiments to do with stuff like that, where it's about creating medicine that helps in your body.
Mm-hmm.
So you would need something with a very high K value in order for it to.
So you would make deliberate decisions about what you would make that antacid tablet out of, so that when it's in a low pH environment, you know that it's going to work. If that tablet doesn't break up at all,
Swallow the rock.
it's not going to resolve your tummy troubles. It's just going to pass through, and you're going to be in agony for about 24 hours because you haven't dealt with the tummy issues. So it takes about 24 hours for your body to consume something, digest it, and get it out. Sometimes it's shorter if it doesn't like it. It will bypass some of that digestion and try to get it out as soon as possible. Think about it. You've all had that happen, right? Where you eat something and it's a bit off, and then you have diarrhea for like the next few hours. Your body's trying to get rid of it. We can also manipulate KSP values. So if we want to prevent something from dissolving, we could add something to it. Let's take the example of Stefan's barium drink. Okay. We know that this already has a very low KSP value. I think it's 1.1 times 10 to the negative 10. Okay. So, if I just rewrite this so that I have something to refer to here. Okay, let's go back to the Chateauneuf's principle. How can I make sure that I don't get barium ions? I don't want.
You don't want barium?
Do not want Ba2 positive. That's what's going to be what makes me sick. I want to lock that up as much as possible with BaSO4. And that way, those barium ions are not going to be available to make me sick.
Create a left shift by adding SO4.
Oh, that's right. I want to create a left shift. What are some ways?
Adding more.
A lot of sulfate. Add more sulfate.
Yes. Because if I add sulfate, I'm going to force that to the left and lock up more barium. Would I add more barium?
No.
Well, if you're trying to get rid of the barium,
Yeah, you wouldn't add
adding
more.
more barium would be the best thing. So, common ion effect. What do you think that's about?
Kaya.
That's okay. Good assumption.
Yeah.
Okay, what do you think first when we say common ion?
They both share.
If you haven't something in common with something. What does that mean?
A similarity.
Exactly.
It's the same.
So you said that if I added something with sulfate in it, I could force a left shift. I'm adding a common ion. And by adding a common ion, I affect the solubility of barium sulfate. That's the effect.
Actually, that doesn't make sense, right?
Well, you could have just
I tried
made
saying
sense
false,
this way.
but I actually didn't understand. I do that through quite a bit of Jesus matches.
You're just like,
Yeah.
Use that words. Where's the worst side?
You just laugh every time you get it.
Yeah, because it's not going to be funny after they explain it either.
I want to sit there, but there's stuff.
No.
So like.
By adding a similar ion, I reduce the solubility of the compound. Use this example to help you out with that. If I add more sulfate, I'm going to have a left shift, and more of that barium is going to be locked up in a compound. So I'm actually decreasing the KSP value even further. And I am decreasing the solubility of barium sulfate. This can be very important if you don't want certain ions to be around.
you're telling me I want less seconds and more distance.
Another real life check.
Try practice problems 2 and 3.
I want more seconds.
You take away